was the thank goodness for air conditioning boogie. And I was sweating too much outside and my phone overheated. So let's get back to lesson 5, activity 1, 2a. Determine sine theta and cosine theta if theta is obtuse. Okay, what does that mean? Okay, we're gonna have obtuse means your angle is greater than 90 degrees and less than 180, yeah? And the tangent of the angle is, tangent of theta is negative 2/3. So please pause this, give this your best shot. There's 2 ways to work it. I'll work it both ways. And, one using those identities we just talked about. And the other way is just drawing a triangle and figuring it out. Okay, ready, pause. Okay, we're back. I'm going to figure it out my favorite way without using all those identities, which identities are cool and you might really dig them because you're good at memorizing stuff. My old brain, I just go back to right triangles, right? So first, let's pay attention to where it is. It's obtuse. So let me, so what does that mean? And, we're always using this coordinate plane. That means I'm over in here somewhere. I'm over in quadrant 2, yes. And I can try to be fairly accurate. I got tangent is 2/3. Well, that means it'd be a 2 on the opposite and a 3 on the adjacent. I'm not using identities here. I'll do it in a minute. It'd be something like that. I don't know how accurate that is or not. This side would be my 3, negative 3, right? And that'll affect my values of sine and cosine, yes? And I'll be a positive 2. That way I'd have a tangent of theta. And it doesn't say get theta. It doesn't say determine theta. We could just take tangent inverse of negative 2/3 and it'd give us our theta. But so how can we get sine and cosine here? It's pretty darn simple. So I got both legs. I need to find the hypotenuse. What do I use for that? It is actually the most famous and possibly the most useful theorem in all of mathematics. If your teacher ever asks you, what's the most famous theorem in all of mathematics? A theorem is a conjecture that's been proved multiple times or whatever, it's something we use. Okay, it's the Pythagorean theorem, right? So I got leg squared plus leg squared equals hypotenuse squared. 2 squared plus negative 3 squared equals, I'll just call it h squared, hypotenuse squared. 4 plus 9 equals h squared. H squared equals 13. H equals the square root of 13. So then I just set up my little right triangle here, and it's easy as that. Now, right, I got sine of theta equals opposite over hypotenuse, 2 over square root of 13. Multiply by, right, you've done this a million times, I bet. Doesn't hurt to review here where we are in late July, right? Got this big test coming up that you want to score well on, right? Just practice. So there's my sine. Sine of theta is that. And it's positive, right? Because the y is positive value. And cosine is going to be negative. We know cosine of theta equals adjacent, negative 3 over square root of 13. Multiply again by square root of 13 over 13. You get negative 3 square root of 13 over 13. Okay, well, in math, I've probably already said this about 15 times to you. I'll just say 16 right now. You can do it second way, right? The second way. So what do we know? The first one I'd be like, oh, well, tangent and sine and cosine. Well, tangent of theta equals sine theta over cosine theta. And so sine of theta, here's where you'd make a mistake, right? Here's what I would just jump. If you were one of your, I don't know. Anyways, you could make the mistake of being, well, it's negative 2 over 3, so sine of theta is negative 2 and cosine of theta is 3, or vice versa, 2 and negative 3. No. You can't You can't assume that. That's the ratio of the two to one another, but that's not this is not the value of sine theta, and that's not the value of cosine theta. That's just the value of tangent theta, and sine and cosine are such that, when you divide 2 square root of 13 over 13 and you divide it by negative 3 square root of 13 over 13, you do get negative 2/3, but sine of theta is not negative 2 and cosine of theta is not 3. Okay? So we got to use something trickier than that. So what was one of those crazy ones? Okay, let's see. What was one of the more silly ones? There's two of them. Okay, let's go back to the part that I can remember. Sine squared theta plus cosine squared theta equals 1. Anybody can remember that. Even I can remember that. And then if I divide everybody by sine squared theta, I get 1 plus tangent. No. Cotangent. Cotangent squared theta equals 1 over sine squared is cosecant squared theta. Now, how the heck can that? That doesn't have tangent, sine, or cosine in it. But I know my inverses, right? So if I take 1 plus, I've got tangent, negative 2/3, right? I flip it over, I'll have negative 3/2 squared equals cosecant squared theta. Okay, this is where you're getting real tricky with it, okay? If you can remember this guy, divide everybody by sine squared theta, and in a minute we'll divide by cosine squared theta to get the other one. And then I got cotangent squared. Well, I take tangent, do the inverse, that's cotangent, I square it. I got this relationship, so I'd have 1 plus 9 over 4 equals cosecant squared theta. Okay, so then I'm going to have cosecant of theta equals the square root of, I'm just going this way, right? And I'm taking the square root of, what would this be? This would be 4/4. 4/4, 4 plus 9 would be 13 over 4. Right? 9/4 plus 4/4, and I'm taking the square root of it. So I'm going to have cosecant of theta equals the square root of 13 over 2. Now, and cosecant, what's the inverse of cosecant? Sine. So, this is getting too crowded, but here we go. So, are you following all this? I don't know if you like this kind of mental gymnastics or if you just hate this stuff. I hope you can see some of the fun of it. It's just a game, and you got some pieces of a puzzle, and you're putting the rest of the puzzle together. So now I know that sine theta is inverse of that. 2 over square root of 13. And multiply by square root of 13 over square root of 13 again, right? And you'd have 2 square root of 13 over 13. And it is, sine is positive when the angle is obtuse, right? Remember that? Okay, so do they match? Sure enough, 2 square root of 13 over 13. Isn't that crazy? So I did the first way with just regular trig functions and, finding the hypotenuse and just using sine, what is sine? And the second one, I use a crazy trig identity, and I think that's what they want you to do, but they don't tell you how to do it, so you can do this way. And maybe I should just leave the other one to you. Okay, you see what I did there. You can work this trig identity if you haven't already, and the video is already over 10 minutes long, so I'll let you do the other one. You would just, to get cosine, you're going to divide by cosine here, They're going to get 1 plus, you'll get 1 plus tangent squared equals secant squared. Okay, and do this same thing. Okay, so I'll let you do that. All right, now we'll go on to 2b. So hopefully that helped you, huh? Getting the answer 2 ways is cool. Okay, so I hope you'll go ahead and work that other way if you haven't done it already. Start with this identity, this one that we can totally remember. Sine squared theta plus cosine squared theta equals 1. Divide by cosine squared theta. Get your identity, substitute what you can substitute, work it out. This is, if you can do this, you're going to do great on the SAT.